Welcome to EleNa. Upon launching our web application for the first time, you will be prompted to grant us location access. Upon doing so, the map view will center on your current location. If you deny location access, the initial map view will be of the whole world, but the application will otherwise work as intended. We will start with a quick tour of the user interface. On the left side of the screen, we have the map view, which is powered by Leaflet. This map is interactive in that it allows for both panning and zooming. Over on the right side, we have the input form. First up are the text fields. These are for the start and end locations and can handle natural language inputs such as street addresses or actual names of places. Below that, we have a slider for specifying the acceptable % increase in lateral distance. Below that, we also have buttons for computing the route and for the elevation choice. For the first demo, we'll show how the application handles bad inputs. First of all, much of the input validation is handled by the form itself. That is, we prevent the user from not providing an elevation choice, as we have a default option pre-selected, and there's no way to unselect it without first selecting a different option. As for the text fields, we inform the user when they've entered locations that are not recognized by our API. Here's just a quick example of that. As you can see right here, we just say unknown start location, unknown end location. We'll now compute an actual route of interest. Specifically, let's compute the minimum elevation gain between Smith College and the Florence Pie Bar. We can leave the max % increase at 50 and just press compute. So as the route is being computed, as you can see, we've got these blue loading dots. Well, they're gone already, but it was just sort of to show the user that the site is actually working and all that. But as you can see, we now have the route displayed on the map with this red line, and the map is still interactive, as you can see. And we've also got the start and end locations displayed when you just hover over these markers. As you can see, we've displayed the elevation gain. It's 44.08 meters. And we can also just take a look at the true shortest path, which, as you can see, is a bit different. And the elevation gain is a bit higher, which makes sense as we were ignoring elevation. And then also just the max elevation gain of 54.01 meters, and that's what the route looks like. Note that we can quickly switch between these three routes because we've computed all three already and then are just switching which are being displayed. We can now increase the max % increase, and this should be a bit quicker to compute. Oh, as you can see, it's super quick this time, and that is because we've already cached the graph and don't need to make all of those API calls. Finally, we'll just conclude the demonstration with a longer route, which is going to be from Smith College to UMass. And let's just maximize the elevation gain and, I don't know, let's say 35% max increase. This one will take a bit longer to compute as it is a much longer distance. But some other important things to note. Once again, we've not hard-coded any of these locations, and the system can handle actual street addresses as well. Just a bit easier to demo simple things, just like Smith College, UMass, etc. So we'll just give this a little time, have it load. Yeah. All right, it is all set. So this is the max elevation gain that our algorithm has computed for us. And as you can see, it says 94.02 meters. The true shortest path has an elevation gain of 64.21 meters, and then the minimum is down at 54.79 meters. Awesome. Well, hope you enjoyed our demo.